T and B, tangent normal, binormal. I'm not going to spend too much time on this, and I know that some of you might feel this is the thing you might be struggling with the most, but I swear, I'm only going to ask you maybe one question, maybe two. Just make sure you know this stuff. There's some formulas at the top that tell you how to get the tangent, binormal, and normal. You can also do, you might write this one down if you'd like. There's also this guy. I don't know if some of you have seen this guy. Have you seen that before? T cross N is B, N cross B is T, B cross T is N. And if you go backwards, it produces a negative. B cross N is negative T. N cross T is negative B. T cross B is negative N. Keep that in mind. Okay, so what's up?
I've seen that with IJ.
No. T, B, and N describe things that are going to go way over your head if they kind of go over mine. They describe like the motion of this curve in space. So if we're talking about, here's a path of a B, right, just going all over the place. The capital T represents the tangential, or the tangent, a vector tangent to the motion of the B. N represents the normal component. So as far as circular motion goes, here's at this point, that's the tangent, right? The normal points inward, because here's what the normal signifies. Eventually, this tangent vector is going to do what? It's going to point that way, right? So it's tending toward this. It's tending toward this vector. You see how this normal vector is pointing this way? It says eventually, if this were to go on forever, that tangent vector will start pointing down. So this tangent vector, and it will eventually start tending toward this guy, right? The binomial vector, fuck if I know what that's for, right? So don't worry too much about that. But you might be asked to find what the binomial vector is for a given vector function. So RT equals T squared, T cubed. Okay. So we're going to go find T. Let's find T first. Okay, so when I plug in 1, I get 1, 2, 3. So capital T, let's say of 1, would be 1, 2, 3 divided by the square root of 1 plus 4 plus 9. T, N, and B are all unit vectors, so I'm making that a unit vector. B is given by the formula in the top middle of your page. R prime cross R double prime. So I have to cross these vectors really quick. 12 minus 6 is 6. Well, minus 6 is 6. Negative 6. This would be B, except it's not currently a unit vector, so we have to divide by. What's my mind? 1, 2, 3, 0, 2, 6. Oh. 2, 0. Alright. Okay. 6 squared is 36, plus 6 squared is 36, 72, plus 4 is 76. Weird. Which is 4 root 19. Okay. Alright. It doesn't look right. I feel like I go somewhere, but whatever. All right. So that's B. This is T. This guy B.
But then the weight, what does that mean? Inertial force?
How do I get N from B and T? Cross them. I'm going to do B cross T. Now here's what you're probably thinking. Ugh. Gross. Gross. Right? Here's what matters. I'm going to eliminate. For our purposes, we're going to eliminate. I'm just going to factor that out. I don't care about it right now. I'm just going to cross B and T. So here's 3, negative 3, and 1. Really what I'm taking from this is I'm the direction or the magnitude is going to be all wrong, but I'll make it a unit vector in the end anyway, right? I'll divide by its magnitude in the end. I'm getting the direction from this guy. I'm getting the direction from this guy. Negative 9 minus 2.
Yeah.
Well,
It's just
just because of
Minus 2. Negative 9.
which way are we taking one?
9 minus 1.
Y is up, I guess we could say.
6 plus 3.
So it depends how you want to do those splits. It's accelerating
Now, this would be our normal vector, except this would be our capital N. Oh, what do we have to do first? What do we have to do to that? We have to make it a what?
Well, I'm wondering.
Doing Calc 3? No? Okay, fuck off. Okay. It's not currently a unit vector, so we have to divide by square root of 121 plus 64 plus 9. And then it will be a unit vector. Then we'll be set. So 1, 2, 3 over root 14 is our unit tangent vector. 3, negative 3, comma 1 over root 19 is our unit binomial vector. Negative 11, negative 8, 3, all over squared blah is our unit normal vector. Good? That's how you find those. Alright, we're done with the review. To talk about some true and false questions if you guys want to talk about that. You guys are free to go though, and I'm just going to keep doing problems until you guys are happy. Cool? And that was what was essentially a 2-hour review, because we kind of started at 6. So I kind of covered almost everything in a really short span. I might have skipped some stuff about the acceleration components and the tangential components of acceleration and normal components of acceleration. That's something you can read up on later, but I've covered most of it. Good, I went pretty fast. So true-false questions that Kieran likes to ask. Okay, the intersection of y squared equals x plus z squared with the plane x equals 1 is an ellipse. How do I do that? Well, it tells you x equals 1, right? Tells you x equals 1. If you plug in 1 for x, you get y squared equals 1 plus z squared. Right? If I subtract z squared over, is that an ellipse? This is a shape you guys probably haven't thought about, probably seen before. This is a hyperbola. So the answer to this is false right off the bat. If you wanted to see an ellipse better, Dan will see something like this. Now, technically, this is better known as what? In the plane, x equals 1. So this would be a cylinder in space, but we're looking at a particular slice of that cylinder. If you slice a cylinder, what cross-section do you see? You see a circle, right? This would be a circle. Technically, circles are types of what? Ellipses. This is an ellipse. It's more specifically a circle. But you wouldn't be wrong in calling this an ellipse any more than you would be wrong calling a square a rectangle, because a square is a type of rectangle, right? To be more general, this is an ellipse. How does it differ from a circle? We have the y squared and the x squared, or the y squared and the z squared like we have here, but the coefficients of y squared and z squared are different, 4 and 36. Right? And any time the coefficients of x squared, or x squared, y squared, or z squared, and y squared, or whatever, differ, then it's an ellipse. But if they're the same, it's a circle. You could also have, this is all, again, when you're dealing with a minus sign here, it's a hyperbola.
We're going to run
In case you're curious to know what a hyperbola looks like,
K1 equals 20. What's K2?
it's a hyperbola.
And then
Circle.
what's the third situation?
An ellipse.
Situation is what we just did.
Good? Looks like a face.
Oh,
The same.
2 eyes, nose, mouth.
One has
Right.
20, one has 25.
It just says
Number
when
2, the plane 3x minus 4y plus z equals 11 is perpendicular to the plane x plus 2y plus 5z equals 2. How do you check to see if two planes are perpendicular? If the normal vectors are perpendicular, how can you glean the normal vectors from the planes? There's just the coefficients of x, y, and z. So the first plane's normal vector, 3, negative 4y plus z equals 11. That normal vector is 3, negative 4, 1. The other normal vector is 1, 2, 5. If you dot those, and it's 0, then the planes are normal. Turns out, you guys want to dot that really quick? 3, what, 3, negative 4, 1?
wait, why that?
Dot it with 1, 2, 5.
Oh, we're doing that. Okay, that's right.
3 times 1 is 3.
So
Negative 4 times 2 is negative 8.
So,
1 times 5 is 5.
so the
3 minus 8 is negative 5 plus 5 is indeed 0. So check, it's true, these two planes are perpendicular. Alright, number 3. The equation y equals 4 represents a plane that is parallel to the xz plane. This is the question. X, y, z. For our purposes in Calc 3, I tend to put my x-axis is coming out toward us, y to the right, z is up. You can think of this as a hotel, where this is the ground floor. The xy plane is the ground floor, and the ground floor corresponds to z equals 0, the 0th floor, right? But anytime you go up, if you're up here, in the penthouse, you're at z equals 10 or something. Okay, you're a few floors up. Notice that this plane z equals 10 is parallel to what plane? The xy plane. So what do you think about y equals 4? What plane would that be parallel to? Yes, right. It's the, and this is what I call the Andrew Eleanor patented odd man out rule. Who's missing from the xz plane? What variable is missing? Y. And what do we have here? Y equals 4. Check, so we're good. Make sense? If it was x equals 4 parallel to the xz plane, that would be false, because that would be a plane that essentially intersects the xz plane. Good? Alright. If u and v are unit vectors and their cross product is a unit vector, this is hard. You can always come up with a couple of examples to some. We can sure. I'm gonna come up with. Give me some vectors. Some random vectors. 0, 2, 4, 3, 3, 2. We should make them unit vectors. So this would be 2 over root 20. 4 over root 20. That's a unit vector. And this guy would be 9 plus 9 is 18 plus 4 is 22. So 3 over root 22. 3 over root 22. 2 over root 22. Those are some ugly numbers, but it's fine. We'll live with it. If you cross those vectors and you get something that is also a unit vector, then you'll know that it is true, or it seems to be true. And if you cross them and you get something that is not a unit vector, then you'll know that it's false. It's kind of hard to do. It's kind of hard to concoct examples on the fly, and you're not even sure. Even if it is true, you say, well, I tried one example. Maybe I tried the one example in the world that works, and it looks like it's true, and it's actually false in general. So let's take a look at it from a different standpoint. That's a formula that relates the sine to the angle of the two vectors and their cross product and their magnitude of those vectors. What do we know about u and v? It was already conjectured that those two, or we were already told, we were given that those two vectors, u and v, were what? Unit vectors. So they're 1, right? Their magnitudes are 1. 1 times 1 is 1. What remains is that we have a cross product that equals sine. The magnitude of cross product equals sine theta. Sine theta can be anything. Sine theta can be any number between what? Oh wait, sine theta can be any number between what? Negative 1 and 1. So if it's something like 1/2, what is it saying about u and v? The magnitude of u and v. It's saying the magnitude of u cross. I should say the magnitude of u cross v is what? 1/2, which is to say, is this guy a unit vector? If u cross v is a unit vector, then its magnitude is what? But it's currently, and again, this is just because sine theta can be anything. Let's put it this way. Can I have 2 unit vectors? Here's a unit vector and it's length 1. And then another unit vector. So that it also has length 1. And the angle between them is, I don't know, 30 degrees. Guess what the sine of 30 degrees is? 1/2, right? But look, I have a unit vector here and a unit vector here. Their cross product would have a magnitude of sine of sine of 30 degrees, which is 1/2. The only way you can get the cross product of two unit vectors to equal or have a magnitude of 1 is if when is sine theta equal to 1? Pi over 2. Is if those two original vectors you were given were added at a 90-degree angle with each other. 1, 1. The cross product of these two vectors will have a magnitude of 1. But there's no reason to think that they have to be. They don't have to form a right angle. I just said two random unit vectors. So you can come up with two random unit vectors or take a look at the formula. So this is in general false. The next one, u cross v over the magnitude of u times the magnitude of v is equal to sine theta, where theta is the angle between u and v. True or false? No. Why is it false?
It's supposed to be a magnitude on the top.
There's supposed to be a magnitude on the top, magnitude of u cross v. This is one of the ways Kieran will try and trick you. So he'll present you with a very familiar looking formula and just change one small thing and make it false. This is one of the things he'll make false. He won't put magnitude bars on those guys, and it'll make it untrue. So it's false. This is one small tricky thing. We have u cross v is equal to negative v cross u. That much is true. We know it's anti-commutative. If you switch the order of the cross product, you negate the value of that cross product. What about u cross u? U cross u equals 0. Why is that false?
Oh, it's not a bold.
It's not a bold 0. It's not the 0 vector. U cross u better damn well be bold 0, not just the number 0. Or you could put 0 vector like that. Okay? For every continuous curve R of t, the vectors t, n, and b are all non-zero. This is a tricky one. I put a star next to this. This is the one that separates the a's from the b's. So in order to show something's false, you just have to come up with what? So it's a good word that starts with the word C. It's a long word. What's up? Close. Counter example. We're going to have some wacky counter example. We're going to look up some counter example. Maybe there's some counter example that's very simple, for which we think there might not be a tangent vector or a normal vector or a binomial vector. What's a good simple example we can do? What's a good simple curve we could do? We could use to show that this is false. Okay, no problem. See ya. No problem. What's a good counter example we could use? What's one of the simplest curves you can think of? And that it doesn't curve at all. A line. Let's do a line. So here's a line. Let's go ahead and find t. You know, it's r prime of t over. That would be 1, 3, 2 over square root of 14. Okay? Notice there aren't any t's left over in here. When I take this derivative, am I going to have any t's left over? No. No matter what value of t I'm looking at. Okay, let's go find n. How do I find n of t? This requires that I do t prime of t over the magnitude of t prime of t. What is t prime of t? What is the derivative of 1, 3, 2? 0, 0, 0. So what do you say about this? What about this guy? We're running low on battery power. What's that? This makes this true or false?
False.
False, because it says that for any continuous curve this would have been non-zero, and yet we got a 0 vector. It's almost kind of hard though. Don't expect a problem with this, but you kind of have to think outside the box for that. The non-zero vectors, oh, this is great. U cross v, and u cross v are all perpendicular to each other. Holy shit. U cross v, and u cross v. Are these guys all perpendicular to each other? Let's start with this guy. If two vectors are perpendicular, then when you dot one with the other, you should get 0. What do you guys think would happen if I dot u with u cross v? We did a problem like this earlier. What does u cross v give us? It gives us a vector that is what? Perpendicular to u and v. And so when I dot u with a vector that's perpendicular to u and v, I should get 0. That just makes this definition from a definitional standpoint. U cross v is a vector that's perpendicular to u and v, so certainly u is perpendicular to u cross v. These two are good. How about u and u cross v? U cross with u cross u. Just these two. if I dot u dotted with u cross u. What is this? This produces a vector that is perpendicular to what? Both u and what? No, careful. This whole thing produces a vector that is perpendicular to u and what?
U cross V.
The vector u cross v. This vector is perpendicular to what? U and
U cross V.
so u will be perpendicular to this vector, right? Because after all, again, if you want to, this vector is perpendicular to u and u cross v. So certainly u will be perpendicular to this vector because it just says this vector is perpendicular to u and u cross v, so u is perpendicular to it. So we're good here. How about these two? What is this vector? This vector is a vector that is perpendicular to what? This third vector here is perpendicular to what? And so u cross v is perpendicular to this vector because you just said it. This vector is perpendicular to u and u cross v. Make sense? So this is true. Kind of a hard one. Ooh, in space, I actually crossed this one out. He didn't cover this one, but briefly, I borrow this. In a plane that is in the surface of this table, or else do it up here, two lines are either parallel or at some point they intersect, right? Going on forever, they eventually intersect, right? In space, though, you could have they're parallel, they intersect, or you have this happening. Are they parallel? Do they intersect? No. These are what are called skew lines. So in space, you have three possibilities. Either they're parallel, they intersect, or they're skew. If you haven't heard the word skew before, then don't worry about this. Okay? It's just a fun problem. This is a tough one. If u, v, and w lie in the same plane, then u cross v dotted with w is equal to 0. I'm going to roll three vectors. Okay, we have three vectors. They are all in the same plane. Namely, they're all in the plane of the what? The whiteboard here. These vectors u, v, and w are all in the plane of the whiteboard, and we want to know if u cross v dotted with w equals 0. Well, u cross v would give you what? A vector that is. You know, I'm saying it a lot now, but u cross v gives you a vector that's what? Perpendicular both u and v. That vector would point where? Out of the board. It would point out at us, right? So here's u, here's v. Their cross product would point out of the board. And what would you say about this vector, this black marker, and w? What would you say the angle formed between them? 90 degrees. So their dot product would be what?
0.
So I'll run it back one more time. U and v are here. Their cross product is the vector that points out of the board, right? Now if you look closely, you can see that here's w, here's the cross product of u and v. There's a 90-degree angle here. So their dot product is 0 because they're perpendicular to each other. Good? Alright, next one. There exist vectors u and v such that magnitude of u equals 4, magnitude of v equals 5, and u dot v equals 12. This is kind of a hard one. Go ahead and just mark it as true. It's hard to answer this question in context of true before I put it in context of false. So let's suppose for a moment I said, these are the numbers I gave you, right? Suppose for a moment I have that though. Alright? Let's suppose for a moment I have that. Why is this not possible? Let's have a look. Remember, cosine theta is equal to the dot product over the magnitudes, right? Dot product over the product of the magnitudes. What is the 21 over, this would be 21 over 20. Why is that not possible?
Is greater than 1.
The highest value that cosine can take on is 1, and yet here on the right-hand side we have a value that's larger than 1. This is not possible, is it? You can't have a dot product that is more then the product of u and v, the magnitudes of u and v. Because the right-hand side would be a number that's larger than 1, and you can't have a cosine equaling a number larger than 1. Can you? What angle theta is cosine theta equal to 2? Never. It's never true, right? So if it's 12, that's 3/5. Can you guys come up with some angle for which cosine theta equals 3/5? Yes, it's possible. You probably should grab a calculator for that point. For that guy, right? It can be done. Okay, next one. If an object's position is r of t, then the speed is... Yeah, it's just a definition. No. Okay, we're good. That's just a definition. Let's just go with true. That's just actually, that's a formula I want to memorize. The speed of an object is given by... This looks like the arc length formula, doesn't it?
Yeah, I thought speed was the magnitude of the velocity.
Good point. Yes, exactly. The velocity. So what would r prime of t be? That would be dx dt, dy dt, dz dt. Excellent point. Yes, you're exactly right. So if r of t is x, y, z, then r prime would be dx dt, dy dt, dz dt. What's the magnitude of this vector? Square each of these guys, add them up, and do what? Square root. Cool. Good point. All right. If u and v are perpendicular, then u dot v is equal to bold 0. True or false?
True.
When you dot two vectors, what do you get?
Oh, scalar. I was thinking
Scalar,
of
right?
cross.
Right, let's say not a cross product. When you dot two vectors, you get a scalar, not a vector. So bold 0 is wrong here. It should be a nice skinny 0. It should be a scalar. So it's false. Okay, what is k cross k? What happens when you cross the vector with itself?
0.
You get the 0 vector. And when you dot the 0 vector with anything, what do you get?
0.
Yeah. This is the number 0. So this is the number 0. The right-hand side, no matter what you do, it's going to be something cross something. What happens when you cross two vectors? What do you get? When you cross two vectors, you get a what? A scalar or a vector?
Vector.
So they have a scalar on the left, but what would only be could only be a vector on the right. So this is not possible. That's one reason it's not possible. Better yet, k dot k is going to be what? Whenever you dot two numbers, what do you get?
Scalar.
Sorry, when you dot two vectors, what do you get? A scalar, right? Did I say dot two numbers just now? When you dot two vectors, what do you get? You get a scalar, right? You get a number. So you have a number. Can you cross a number with a vector? No, it's not even possible. You can't cross a number with a vector. It's not possible. And in fact, there might be some problems like, which of these is possible? Can you do u dot u cross v? Can you do u cross u dot? This one you can do, because remember, the inputs to both the dot product and cross product operations are vectors. So u and v are vectors. They take in vectors. What does it spit out? What does u cross v spit out? A vector or a scalar? A vector. Can you do a vector dotted with a vector? Yeah. What does u dot v spit out? Scalar. Can you cross a vector with a scalar? No. So this is possible. This is not. Make sense? T, N, and B are all unit vectors. Yeah, that's just the definition. Kind of we talked about that earlier in the T and B frame. They're all unit vectors. The shape. We're not going to talk too much about shapes. Actually, the last 5 are all shapes related. We'll do the first 2 of those. Actually, we'll do the first 3, but we're not going to do the last 2. Okay. It seems as though he doesn't care too much about you knowing shapes, but.
I mean, he was saying that if we do have any questions,
It'll be traces,
it'll be like a conceptual.
Okay.
One like this.
Okay. This one you should know. This shape is a cone. It's a cone that opens upward along the z-axis. Actually, if you do z squared equals x squared plus y squared, so this is a cone that opens upward along the z-axis and opens downward along the negative z-axis. This is called a cone. This is called a double napped cone. Might be a phrase you've heard before. Double napped cone. Don't know why. Double napped cone. Anyway, notice this is opening up along the z-axis. Which axis does the cone specified here open up along? Y equals square root of x squared plus z squared. Have a guess. Who's the odd man out? Who's the odd man out? X, Y, or Z? in the equation y equals square root of x squared plus z squared, who's the one's not like? Which of these is not like the other?
Why?
Y. Y isn't like the other. So y-axis is surely open up on the y-axis. Good. If I say y equals, I don't have to draw it, and I know it. Here's your cone.
So your time was what we were set on.
I want to also draw one more thing.
With 1.3, 1.3.
These look very similar, and people confuse them all the time. They got to a point in the last exam, final exam for this class, where I would start asking people, "What shape is this?" And they would guess, "Oh, it's a cone." And I would say, "You all disappoint me." It's just no one remembers. That's a cone. This is a paraboloid. It's kind of like a bowl. I draw a little bit nicer. Well, this would be a good time to talk about traces, actually. He might ask you about the traces. So the traces that are parallel to the, or we might say, what are the xy traces? The xy traces, you could do it this way. What are the xy traces of z equals x squared plus y squared? Actually, let's say 4x squared plus y squared. Let's make it a little harder. What are the traces of z equals 4x squared plus y squared? What are the xy traces? When I ask you for the xy traces, you fix z to be a number, usually a positive number, because you can't have a negative number equaling some sum of squares. Let's say 1. Okay? What shape is this? In a plane. Ellipse. And if you were to look top down along the z-axis, what would you see? Ellipses. Unless I made it circular, but you can't really tell based on my perspective here. No one's like, "Oh yeah, looks more like an ellipse." No. It's only a circle to me. No, you have to do it based on the equation. Now, what if I ask you for the xy trace or the xz traces? We're going to let y be a number. Let's let it be 1. What is z equals 4x squared plus 1 going to be? Some people find this hard because they see the z and they don't know what the fuck they shit their pants, right? If I gave you y equals x squared, what curve is that in pre-calc? What's this? Same answer. It's a parabola, right? It's just you're looking along the y-axis now. If you're looking along the y-axis, what do you see? See a parabola, don't you? You would see parabola there. You'd see a parabola there. So looking along this direction, you see parabolas. What do you think you would see looking along the? What are the zy traces? What would you see? Parabolas. Again, you could do this from based on this. Let x be a number. Let it be 1. So you get z equals y squared plus 4. Once again, one of them is squared, one of them is not. That's a parabolic shape. So the xz traces are parabolas, the yz traces are parabolas, and the xy traces are circles. Cool? Oh, not circles, sorry.
So if a question on those would just be like this, you'd have to say what
You might say what type
is.
of traces. Yep, that was actually question number 1 from his second exam a few semesters back. The traces of the equation. It was literally just x squared plus 4y squared equals z. Almost exactly like that. Almost exactly like the line just there.
So you just let one of them be a number, and then you.
If that's for the xy traces, then you let z be a number.
Okay.
Right? It was kind of messed up because everyone knows that x squared plus 4y squared equals 7 is an ellipse. One test got that, another test got this. What's x squared minus 4y squared equals 7? What shape is that? Hyperbola. Remember the x squared minus y squared or x squared minus hyperbola. So whichever half of the class was unfortunate to have the gold version of the test. I'm like, oh, I don't know what the fuck shape that is. I'm gonna go with ellipse because it looks kind of like an ellipse, but they didn't. They should have known that the minus meant that it was a hyperbola. Cool. And lastly, we're not even gonna do the parabola one. That's just too much. Cool. There's some more. You can ask me
Are
questions.
these F or Q?
Yeah, those are free response question types questions. You asked to be invited to do it? No? Who are you then?
Sean.
Oh,
That's
that's
fine.
why he didn't.
Sorry. Power. That's not trying to do.
Oh, right. Okay, nice. Okay. Well, So those of you who aren't in the Facebook group, you might want to add me, Andrew Eleanor. I'll write it down in case you want to write it down. Lowercase, great. Don't even do myself the dignity of giving myself capital letters. I guess for those of you watching, you might want the name. If you're watching, you're probably already in the group though. There's a Facebook group that I add people to, and I will be answering questions left and right. I'm dedicated to just answering all those questions. Now it's just like the study edge wall in that you ask a question, I'll probably see it a little more immediately because I had to wait for an email to come through when I was study edge, and I wasn't constantly refreshing the wall. And I'm always on Facebook, or I'll get a on this thing, so I can answer it then. There are like 6 free response questions. Those are very, very hard. Those are from when Williamson taught the class. When Williamson taught the class, there was like a collective of 99, almost 90, like 90% of the students wanted to petition, get somebody else to teach it because it was that hard. So those are a little harder. Those free response are a little bit harder. Deal with it. But those other exams that I've attached are a bit easy, and they give you the answer keys for one of them. But if you want to do those later, I know it's been 3 hours now, so we're going to take a stop. I'll stitch this all video together. Watch it online. Hope you enjoyed.